Hi, good afternoon, everyone. My name's Julie Sammons, and I'm excited to welcome you today to the CITRIS Research Exchange. This year, we are celebrating the 10th year of this format, and we're really excited to see all of you here and celebrating another wonderful speaker in our lineup. Our speaker today is Sera Linardi. She's an associate professor of economics at the University of Pittsburgh, and I'll tell you a little bit more about her in a moment. Today, she'll be sharing her work on designing microbehavioral research for practical social innovation. We do ask that you please not interrupt the speaker while she's giving her presentation. There will be time at the end to ask questions. Before I give you a full introduction of our speaker, I do want to let you know that next week's Research Exchange, we have a special guest coming from UC Davis. Vice Chancellor of Research, Prashant Mohapatra, will be joining us, and he'll be talking about impactful research at UC Davis and his work in innovative smart sensing. So we hope that you can join us next week. But on to our speaker today. Sera Linardi is an associate professor at the Graduate School of Public and International Affairs at University of Pittsburgh, where she directs the PittSmartLiving Behavioral Laboratory. She received her Ph.D. in social science at the California Institute of Technology after working as a computer scientist at Adobe Systems. She bridges academic research and practical challenges in the public and social services provision, specifically around prosocial behavior, information aggregation, and behavioral economics of the poor. Her research has been published in economics, management, and political science journals, and also won the 2016 Midwest Political Science Association's Best Paper in Comparative Politics Award. Her work is currently supported by the National Science Foundation and the Heinz Endowment. Please join me in welcoming Sera.
Thank you, everyone. So thanks for having me here. I'm here to talk about the hard work of innovating for social good, right? So doing this is hard work, and it is no less true when we're innovating through technology. So when we're creating something, we put in countless hours to design and build our product in order to bring a specific vision of societal benefit to reality. Okay, so for example, here, Jack Dorsey, the founder of Twitter, explains that he creates Twitter so that people will feel like they learn something and they feel empowered after coming to Twitter. Okay. Online polls and prediction markets are created so that we can aggregate information and we can help people become better informed. And as a result, they can better prepare for the future. So some examples of prediction markets are Intrade and Augur and a lot of different kinds of online polls. Driverless cars are supposed to make driving safer and free us from car ownership and give us back the time that we spend driving. But humans are complicated, right? So the people behind Twitter has assumed that people are altruistic and they're informed, and indeed many of them are. So people have posted accurate and timely information that are literally life-saving, such that of senior citizens that are trapped in Hurricane Harvey, or alternative places to get medicine when there is an earthquake, such as that picture in Japan. But it has also played an increasingly large role in misinformation, confusing us about science and facts, and giving platforms to bullies and harassers that no one can seem to escape from, even if you were the royal family. And more we're realizing that humans don't necessarily use our innovation the way we want them to. Experts on driverless car are ahead of the game here, and they anticipate that instead of improving safety, maybe driverless car can be subject to hacking, and some people can use them potentially into weapons. But mistaken beliefs about the intention of human, like intentional misuse, is not the only thing that we should worry about. Some of the big surprises that we have had has been due to things that are much more innocent about human behavior, such as self-selection. So for example, in 2016, before the Brexit vote, online polls led most everyone to assume that most everyone else would vote to stay in the European Union, right? So this is the stay, and then this is the leave, and for a while, everybody was like, everyone is staying. However, what wasn't accounted for, and this is in many cases in these polls and aggregation markets, is that certain populations, such as the younger or the more educated, are much more likely to participate in this poll. But unfortunately, these are also the population that are less likely to show up to votes. And this could lead into surprising consequences. Right? Okay. So what are we to do? Right? How do we innovate? And how do we understand the humans that make up our society? Some of the ways that we've always used to innovate is we try to understand things intuitively. Okay? So we use self-reflection. We think about our personal experiences. What would I like if I was in this situation? We talk to a lot of people. And this is a process that all social innovators would go through, right? They engage in this to some extent or another. This is fast, it's personal, it's a comfortable process. But the cons is that we don't come into this as a neutral blank slate, right? So we come in with our beliefs and biases. And for example, someone that believed that humans are inherently kind are much more likely to remember instances that confirm their beliefs and discount instances that explained away their belief in human goodness. Another way to think about this humans is through big data, right? So we have piles of data on what humans click on, what humans watch, what humans buy, and with that we can build models that can tell us things like people who follow celebrity A will also follow celebrity B, or people who answer online poll questions on issue A are also likely to answer issue B, right? So here we can create pretty good prediction a lot of the time. We have data-driven models of human behavior, but because we don't understand its underpinnings, we may not quite know how to do out-of-sample prediction. So for example, if without some understanding of the individual level motivation of non-responders in this poll, it's hard for us to think about how would they respond to the poll on issue B if they were a part of it. Okay. And then sometimes we just don't have a lot of data on certain situations. So if we can't completely trust our intuition and we don't have much new data on the new environment, what can we do? Okay. So I'm here to talk about using a microbehavioral approach. So we can turn to first principles, and we can draw on research from people who studies human behavior, such as social scientists. So I think about this process as having the following steps, right? So you have your big problem, you break it apart into smaller individual level problems, and then you put it back together. So it's like break apart and then put back together. So first you want to identify the different kinds of stakeholders that are present. For example, in the Twitter case, it's the Twitter users. And then you want to state your assumptions about them. Like here we say, the users will, Jack Dorsey might say, the users will use Twitter to inform, empower, and help each other. Okay? And then we go into the behavioral and microeconomics research, and we try to formalize our assumption. What does it mean that the users will use our product to inform, empower, and help each other? It means that we think they're altruistic. So then we can test this assumption in a human subject experiment, do an experiment with real humans. So experimental literature have found, instead of altruism being an inherent thing that stays stable in time, altruism is a function of visibility. Are people looking at us? It's a function of social norms, right? What do other people do? What is expected from us, okay? So for example, here, when people are looking at us, when the norms is that we behave nicely, we donate. But when people are not looking at us, when it's anonymous, and we feel that outside of our anonymity, we have a lot of pressure to be altruistic, then the anonymity gives us a curtain in order to engage in unaltruistic behavior. Okay? So we can extend this even further to study communication patterns under different kinds of anonymity or different kinds of social norms. Right? I communicate with others when you can see who I am versus when others can't see who I am. Or you can even use more complex circumstances, like by situations where if I get others to miscoordinate or if I get misinformation, then I can gain from it. And then if we extend this entire series of experiments, we might not be so surprised about the behavior that we're observing on these online platforms. In more complicated situations where we have multiple stakeholders, after we engage in this process and we examine our assumption about the individual kind of stakeholders, then we might want to connect the separate model back up together in order to create a framework for the innovation. Where would the innovation take place, and what are our tested assumptions about the different people that make up this society? Okay, so it's taking your problem, breaking it apart into different agents in the society, formalizing your assumption about these different agents, testing them in a human subject experiment, and then linking back these models together. Okay, so it sounds good, but why aren't there more interdisciplinary partnerships that does this? Okay, so I think there are several reasons. Microbehavioral research focuses a lot on coming up with new phenomenons or on extending existing theory or on technical innovation. So in some sense, I think of it as building cutting-edge structures or building the next level of a high-rise. On the other hand, if you are building for a framework for practical social innovation, you're already in a very messy environment, right? You have a complex situation with multiple stakeholders. So what you need are simpler models. They are modular, models of behavior that can connect with other models and then can become a building block for the particular practical case that you're looking for. So these two different focuses sometimes don't always complement each other, and it could make it difficult it could require the researchers to be a little more creative about how to place their work in traditional disciplinary journals. Outside of the problem of focus within the discipline, I think that interdisciplinary collaboration is just hard, right? So right now I'm working with computer scientists, information scientists, and civil engineers, and the same words such as theory or model can mean two entirely different things. The same level of involvement in a project, like data sharing or being present in a lab meeting where research is discussed, it can mean co-authorship in one discipline, but not in another. Okay. So these differences in approach can emerge in something as simple as running a regression, as you have one group talking about predictive fit and the other group is focused on the interpretation of the coefficients, right? So interdisciplinary research is just hard. But I think it's worthwhile because we need to throw all we can into understanding the humans that we're designing for as early as possible in the process. It may make the process of innovating a little harder, but if we don't, by the time we have enough information to change our minds about the humans that we're innovating for, we might be pretty far along, and it might be pretty expensive to fix, right? So for example, this is recently, Jack Dorsey says, I feel terrible. I want people to walk away feeling like they learned something and feeling empowered, and it depresses me that that's not the general vibe, and I need to figure this out, right? So at this point, redesign, rethink of the platform that you innovated, okay? Right. Okay, so for this talk, what I'm here to show you today is our effort to attempt to do this. So we want to connect the intuitive level, the big data, and the microbehavioral research to some technology-driven and practical kind of social innovation. So we will do this in the context of an ongoing project, so emphasis on still ongoing. It's a multi-year project. It's called PittSmartLiving, and it's an interdisciplinary research effort to improve the experience of public transit at rush hour, okay? And it's funded by a $1.4 million grant from NSF. And my goal today is to share with you more of the thinking process. Okay, so the results are at a preliminary stage, and so what the results that I present here are mostly as an illustration for now. Okay. All right. So the project is hosted at the University of Pittsburgh, and it involves multiple schools. So in the School of Computing and Information, so Alex is the principal investigator, and he leads the data and systems team. Costas is a lead for the newly formed business integration team, and I lead the human behavior lab. We call it the humans. Okay? And there are more grad students and undergraduate students that are involved in the project. You can visit our webpage at pittsmartliving.org to see everybody there. Okay, so I'm going to give you a motivation, just sort of a story about why we got started. So you were standing by the side of the street and you're waiting for your bus, okay? So it's drizzling and you're tired, and your favorite transit app says that the next bus is coming in 5 minutes, okay? So you crane your neck forward in anticipation, you wait. 4, 3, 2, 1. Oh, the bus is here. You're happy? Bus is full. And it passes you. You're sad. And on cue, it starts raining hard. Right? Sad. Has anybody here ever experienced that? Okay. So let's help these guys. Okay. So how do we help this guy? So let me give you some constraints. So first, you can't add more buses. The government either have no money or there's no bus garages left. Okay, bus garages cost a lot of money. You can't change the timing or the prices of the bus ride. Okay, if you want to increase it, people can't afford it. If you want to lower it, Port Authority doesn't have enough money. You may not ask the government or transit riders to put more money in the system, right? So for the purpose of the government and the transit rider, it has to be budget balance. So we're working with what I think of as the difference between a social innovation and a policy change. With the social innovation here, you can only create infrastructures and incentive systems so people will voluntarily take the behavior that you want them to take, right? There's not going to be, let's suppose that we can't create a policy change. So these are our constraints. And let's think about how we can help those guys with these constraints. Okay, back to these two guys. So it would be nice if, so let's use the intuitive way. So it'd be nice to know that the bus is going to be full, right? So if you give them an app, and the app says, in 5 minutes your bus is going to come, but it will be full. That would be nice. And the app can then say, hey, why don't you take a bike share? Or walk a couple blocks and there's another bus that goes close to your route. Or, and this is what I'll focus on in this talk, why don't you turn around, there's a cafe right behind you and here's a discount, and go hang out in the cafe and have a latte on us. Okay, so create a market that is connecting the businesses with the transit riders. And I'm gonna take some time here and talk to you about why I think a market is a great idea here. So first of all, it takes care of the budget constraint that I gave you. Right? We can't ask the government or the transit riders for more money. Okay? So essentially, using the businesses allow us to implement congestion pricing without asking the government or the transit riders to pay for it. And it does this in a way that benefits the businesses. So businesses care a lot about having loyal customers because acquisition costs 5 times more than retention of existing customers, right? So you're more likely to sell to an existing one. And transit riders already have the characteristics that increase their likelihood to be a regular customers. First of all, they're already consistently and frequently physically close to your business. That's a great start, right? Okay. So I think another important thing is that with this market, you are creating a true urban ecosystem. Right? So when previously businesses are sort of just like floating, transits are just sort of like floating around the city with the city as a backdrop, with both the businesses and the transit riders sort of half aware of each other, you are creating a situation where transit riders are no longer just people existing in a bubble, but they're kind of locals because now they're aware of opportunities around them. And then businesses are now much more aware of public transit and the impact that it has on their bottom line. Right? So you're creating an ecosystem. So we think this solution is promising. It may not, it's something that is generalizable. It can be transported to a different city, different situation. And continuing on to the app, so we have the market. What else would we want? Another thing that would be nice is to be able to pre-plan, right? So these are the guys when they're still home. It would be nice to know that at 5 p.m. tomorrow when I'm coming home, this is going to happen and I have these options available to me. Okay? So altogether, this is the PittSmartLiving project. Okay. All right, so how do we do this, right? So I'm going to go to the data and systems work first. So a lot of the work in the data and systems group have been on the bus load predictor. Okay, so this one, telling you that the bus is full. And then the computer science Ph.D. students, Tara and Xiaoting, are working on this using data that is available in Pittsburgh from the Port Authority. So Pittsburgh buses are GPSed, and so we can learn about historical data. This real-time data is new, but we have historical data from 2017 and 2018 on occupancy level, on arrival times, lateness, loading and unloading. Okay. We also have public data of the bus schedules, and when we combine this and clean the data, and then create route stop combinations, number of routes that you have, and then the different stops, you get about 12,000 data sets. And then when you combine this with hourly temperature data, rainfall, snowfall data, you can create a predictive model for bus load and arrival delay as a function of temperature, road events, and routes and stops. Okay. All right, so these are some of the techniques that we've tried. However, as we know, data is messy. Data is created by humans, and humans are not always precise. So for example, in our case, there's a route indicator that has to be turned on and off by the bus driver. And this is not always turned on, right? So for example, a physical bus that was bus 54 and is used as bus 61 today might not be switched. And now you have bus 54 running the route of bus 61. And you have to figure this out. Another thing is that we're in an urban canyon here. And so what happens is it's hard to figure out where we are specifically. And so you see here that the Pittsburgh buses are traveling in the rivers. Right? So you have to take all these little, oddities and sort of try to remap it back to the bus routes. Okay. All right. So once we have the loads, we have the bus routes, we can combine this with data about businesses, and we can map them together and figure out what routes are full at what time, what routes are getting a lot of loading at what time, and then we can figure out how busy businesses are at different times, and we can map the two and then figure out what businesses to approach and what routes to offer coupons to. Right? Okay. Another thing that we might do is create physical infrastructure in order to display the data. And so the team has worked with transit screens and put up transit screens at high trafficked areas such as the city hall in order to have the physical structure to show the data. Okay, all right, so are we done? Is this, so a lot of development of technical innovation kind of stops here, right? And we're like, all right, we've thought through the problem, we looked at all the data that we have, we think about how to execute it, let's go make it, okay? But I think if we dig a little deeper, you might see that there are questions about the humans in the system that we haven't considered. For example, how big should the coupon be so that people would actually shift their travel time? How would the business owners think about this market? Okay? What kind of unintended consequences might happen? Like, could you even worsen congestion with this market? For example, I want a burrito. I want it cheap. I'm going to go stand by the bus stop at rush hour so that I get a coupon and I can get my burrito cheaper. Right? So just thinking through all of these things, these are the kinds of questions that the microbehavioral approach might help with, right? Thinking about the individual level. And so this is what I'm going to talk about for the rest of this talk, is the work of the Human Behavior Lab in PittSmartLiving. Okay? All right, so that's the lab and all the students and postdocs in the lab. So let's go back to the two people on the bus stop, and now I'm going to give them names because we're going to get a little bit more personal about them, right? The micro approach. So it's Camilla and Dawn standing on the bus stop, right? But before we talk about them, let's zoom out a little bit. So we know that these stops here are overloaded, but what we should care about are the stops before them. So let's extend our view from here. So here's the view from here. This is the bus stop before Camille and Don got left by the bus, right? So the bus comes every 15 minutes. And what we want to think about is what is the value on getting on this bus as opposed to the next bus, which is coming 15 minutes from now. So it's the value of your time, your 15 minutes, okay? So using a microeconomics approach, we can think of a traveler as an individual I that is trying to maximize their satisfaction, which we call utility, by consuming goods or services. And this could be the bus ride, or it could be the money that we're going to discount, or it could be the latte they're going to buy with the discount. Okay. So the person that is in the bus stop has already gone through this optimization process and decided that this is the optimal time for them to travel. And so to ask them to delay would cost them time, right? It will cost them utility. So I'm going to call CIT the cost for agent I to delay their travel by T. So we can compensate agent I for the delay by X dollars. That's one way of thinking about it. Another thing to think about is we can charge the agent I X dollar in order to avoid the delay. And the utility in the simple form would be the money that we give them minus the cost of the delay that we impose on them. Okay? Okay. So this cost is not directly observable, right? But we can find this out by using X, the money that we give them. So if someone accepts an amount of money in order to delay their travel, you know that their cost of time is less than that amount of money, right? Okay. So taking this micro view, let's look at this traveler's delay cost. So Anne is watching videos on her phone, and when she goes home, she's just going to do the same. So if there was one seat on the bus, she's only willing to pay $2 for an auction to get that seat, okay? So Anne's cost of time for a 15-minute delay is $2. Bob wants to go to the library, but he has some slack in his schedule, so he's willing to pay $3. Cami needs to get to work, so she's willing to pay $8, and Don is rushing to go home so he can pick up his kid from the daycare. So on an auction, he'll pay $10 to get on this bus instead of the next bus. All right, so if the bus arrives at Anne and Bob's stop with 2 spaces left, they will both get on. The bus will pass Camille and Don. And so the societal cost here of a full bus is Camille and Don's cost, which is $18. If we had a way of preventing Anne and Bob from getting on the bus and having Camille and Don in there, then the societal cost of the full bus would be 2 plus 3, which is $5, right? So you're minimizing the cost of congestion here. But if we had asked Anne and Bob to, can you give up your seat, someone else needs it, they'll be like, I really need to feed my cat, like I haven't, or something really urgent, I forgot to turn off the stove, and so they will protest, okay? So what can we do? What we could do is we could look at another source of inefficiency in the system, which is the businesses, okay? So the businesses around the stop are underutilized. Rush hour times usually don't overlap with meal times. So for example, when buses are full between 4 and 6, businesses are not yet at their dinner peak, but they've already passed their coffee peak hours, right? And so there are empty queues in the businesses. So I'm kind of drawing this as a queue here, the empty queue in the businesses. So let's think, so parts of the human behavioral lab is looking at the businesses specifically. So Logan and Xiaohong from GSPIA are interviewing these different businesses and looking at the literature and asking you, so do you have empty queues in your business, and would you like to participate? What are you thinking about when we talk to you about a discount program? So businesses, the good news is businesses are interested in increasing their customers, especially through mobile or social advertising. But what's not as encouraging is they're very afraid of an unstable customer stream. They don't want sort of like a Groupon situation where a lot of people will come in, crowd their businesses, and then not translate into regular customers. And in some sense, maybe even scare their regular customers. Okay? So the local businesses are focused on locals. They're like, we want the people living here because these are the people that will return. One solution is, what I said earlier, you can make the transit riders behave like reliable locals because they're consistently there at similar times. And you can try to think through the impact that this discount program can have on the current customers. So we have Jing, who is in operations research, think through the model of promotions when customers are delay sensitive. Okay? So this is an extension of a work by Guangwen Kong in 2016. So you have regular customers that are arriving, sort of like a Poisson distribution in a stochastic process, and then they are paying P dollars for the product, and they're waiting, and they go in on their service at a certain time, resulting in a wait time. And they have a certain cost of time for the time that they have in the queue. If you have the discount customers and they go into the waiting time, you will then have a new discounted period waiting time, which is a longer wait time. And then you can compute how that would affect the regular customer and the discount customers, given there's this wait time, and they have to catch the next bus. So in some sense, they're more delay sensitive than your regular customers, right? So you can create a model that accounts for this. And then after that, you can then try to connect the availability of coupons in these businesses to the travelers that are in the bus stops. And this is what Jin Young Jung, which is in our, the postdoc in our lab, is working on. So he's a market designer. And together with the business integration lab, they're thinking about ways of mapping the business coupons to the customers. Okay. All right, so for example, if both of these businesses decide to give $2.50, what you would get is that Anne would take the coupon instead of getting on the bus, and you don't have to find out what Anne's actual cost of time is. And she goes to the business, spend $4.50, producing $2 for the cafe, and the bus will go through the next stop, and Don will get on, and he's able to pick up his kid, but Cami still cannot get on. But this is the societal cost of the full bus now is Cami's cost, okay? It's improved from 18 when Don could not get on. But these costs are not costs that are directly related to individuals. These costs, in some sense, are distributions. So if I had switched Cami and Anne's cost here, so here Anne has to go to work this time, so her value for traveling is $8, while Cami is just replying to emails on her phone, so her value for traveling is $2. In this case, having a market will allow Cami to not be waiting for the bus, go to the cafe. Don will still not be able to get on the bus because Anne and Bob will get on the bus. So in that sense, the market does not change who's on the bus, but it still improves welfare because Cami is not mad at Port Authority. She's enjoying herself, though we still have Don not able to get on the market, not get on the bus, okay? So in this way, the micro view allows us to see the travelers as distributions of cost for delays, and the different bus stops as draws from this distribution, okay? So we're interested in this distribution and its characteristics. And this is how we're going to try to model the riders. So this the appropriate size of the coupon will change depending on this distribution of cost. And this distribution of cost will change depending on exogenous shocks such as weather. Like if it's really cold, maybe the cost of delaying is very high. Or maybe it's lower because you would stand in somewhere warmer or something. But sure, bad weather is probably higher cost. And this distribution will probably change when we're planning ahead or when we're planning ahead versus when we're in the middle of the trip. So for example, if I ask you tomorrow, would you take a bike share home from work or would you take public transit back from work? You say, oh, yeah, okay, I can see how I'm going to fit it to my schedule tomorrow. But when it's actually tomorrow, you're tired, you just want to go home, you're thinking about your dog, you're like, no, I'm just gonna do my regular thing, whatever your regular thing is. So we want to think about how time inconsistency would affect this market as well, borrowing from the behavioral economics literature. So how can we study the behavior of this distribution? So in transport economics, there is survey of travelers. There's much fewer experiments, so there's ways to study this through field experiments and lab experiments. But lab experiments, while it is costly, while the external validity is high, because we're working with actual transit riders, it's expensive to do. So if you, for example, if I go to the bus stop actually and ask people, how much should I pay you to delay your trip by 15 minutes? People will look at you and be like, are you for real? And then you have to stand there, wait for them for 15 minutes to go away, and then come back and then give them their discount. So a field experiment is possible, but it's probably more possible with an app rather than just sending out RAs to bus stops. And the lab experiment is probably a better first step to explore how people's cost of time and the substitutability of money and time would work in different situations. Okay? So our solution is that we're going to do both. We're going to explore the parameters of that distribution of cost of time in a lab experiment, and then we're going to take a small range of that distribution and test it in a field experiment. So the lab experiment is done by Domi Famosi and from our student from economics. So what we did is we recruit university students for an experiment that would take about an hour, okay? And we tell the subjects when they come in that they can leave after an hour. So these are just university students, okay? And then we ask them a series of questions about their willingness to wait beyond that hour. In the second hour, so this is done at the Pittsburgh Experimental Economics Lab. In the second hour, subjects can leave now, but then we ask them a series of the same question that we asked them earlier about their willingness to wait now, right? So we're using this part as pre-trip planning and this part as the intervention during the trip. Okay. So subjects are paid. One of the questions that we ask them will be chosen to be implemented. And so, for example, if someone says, I'm willing to wait for 15 minutes for $5, then if that question was randomly chosen, then they need to wait 15 minutes for that $5, or we don't pay them like a completion fee. And then they can leave the lab after we implement their decision. Okay. So we're trying to kind of take a transport situation and do sort of like a first pass on understanding people's valuation for their time using a lab environment. And then given this, take the findings from this and then move it to the field. Okay. So these are kind of screens that people work with, and it's adapted from this paper from Management Science. So we will ask people, what do you prefer? Do you want to stay an extra 15 minutes for $4, or do you want to leave on time with no extra money? If I click on get an extra $4 and stay an extra 15 minutes, it was sort of like, it's like a funnel design where I would go to the next one and says, do you want an extra $2 and stay for an extra 15 minutes, right? So we'll go on and on until I figure out how much your value for 15 minutes would be precisely. So the lab allows us to test a whole bunch of delay times, such as 30 minutes, 45 minutes, whatever we want to work with. It also allows us to think about uncertainty in delay, like get an extra $4 and a 50% chance of staying an extra 30 minutes, right? So this is like 15 minutes expected wait, but now it's by chance, okay? All right, so we ran some of this. It's a pilot experiment. And then what we get is the following. So this is preliminary results. We still need to get more data. But it's very consistent with the behavioral literature. So for a 15-minute wait, if I ask you before the trip, how much do I need to pay you? You say $2.35. And but if it comes down to the trip time and I ask how much do I have to pay you for you to stay 15 minutes, you say $2.75. So there's a 17% increase now rather than at the pre-planning stage, okay? For a 30-minute one, the difference, there's also this difference of $5 to $5.69. It's a 14% change. And what's interesting is that with a 50% chance of 30 minutes, it's not statistically significant. The pre-trip planning versus right now. Why? People just really hate uncertainty. So if you compare those two, the expected wait is the same, but people are requesting 40% more in compensation for the uncertainty, right? And so here you don't have a big difference anymore, okay? So the takeaway from this is that the coupon size delay trade-off seems to be similar to a wage rate. 50% of the subjects who are planning to wait become more impatient when it comes to the actual trip time and decide to change their minds. And then subjects demand a lot more money when there's uncertainty and delay, okay? So we can take this sort of like patterns of behavior and weights and take them to the field and try to test it in a field experiment, which we are doing. So this is Mallory Avery, a Ph.D. student in econ, and she is running the field experiment. So we're going to run 2 field experiments in Pittsburgh under 2 different conditions. So again, we were interested in how stochastic shocks outside and cost of traveling, cost of delay would affect your decision. So we're gonna run it when the weather is really bad in Pittsburgh, which is really easy to find. It's very cold right now. We don't want to do it during the like bombogenesis or something like that, really super cold time. But we have really cold periods and we have really nice spring weather, right? So we're going to run it to 2 periods. So what we're going to do is recruit people from the routes that we're interested in, and say, do you want to participate in a transport study? They're going to install an app. So this is not the app, the PittSmartLiving app yet. This is a pre-app to study this. To study the findings from the lab experiment to see whether it extends. And the app will tell you, kind of looks like this in the notification screen, and we'll have things that you could click on. After people install the app, we're going to observe their regular transport behavior for a while. And then we're going to actually do the experiment, and I'll go through the experiment in the next slide, which is one of it is offering them incentives to change their behavior. And then we're going to go into see whether or not it becomes a habit, right? Are we only able to change their behavior for a short amount of time? And then once we take away the incentive, they go back to their previous behavior, or is this kind of a permanent change? But the treatment itself is basically the following. So we're going to detect if they're near a bus stop. There's also a pre-planning thing that I don't have time to go through right now. But we're going to detect if they're near a bus stop. If they are, we randomly offer them coupons. This is to take care of the problem of me wanting a cheap burrito and standing in front of the bus stop because I know for sure I'm going to get a discount coupon, right? So it's going to be randomly allocated. So the randomization will be an information-only treatment where I tell you the bus is going to be full, and an information plus incentive treatment. So the information treatment kind of looks like this. There's a notification. It tells you that the bus is going to be full. You may not be able to get on it. And then it asks you if you're still planning to take the bus. So I could see what you plan to do versus what you actually did. And then the information plus money treatment, it will give you the incentive and some suggested action. Okay. So I'm going to stop here, but basically just saying that through our simulation, what we're able to find is that this incentive might be able to lower overload at the targeted time, and it will increase the people traveling 15 minutes after the targeted time, or 30 minutes, or whatever time period that we're working with. However, overall, it will reduce the total cost of congestion because it doesn't increase it to a point where, like, these are very costly overloads, while these are not as costly. But in summary, so what I'm trying to do is just paint one picture of the process of interdisciplinary collaboration and show how this microbehavioral approach can be integrated into this practical social innovation project. It's in progress, so we don't know whether it will work yet for Pittsburgh specifically, because the overload in Pittsburgh is not like too intense as opposed to cities like Seoul or other places. And this might be an interesting experiment for other cities, and if you're interested, please email me. Apart from that, I look forward to telling you what would happen to our project in about a year or 2 years from now when we actually have all the results down. But thank you. Yeah.
If you have questions, please raise your hand so we can come to you with a microphone.
Hi, Sarah. Very nice presentation. To what extent did the external conditions of the weather affect the experiment?
So we have preliminary prediction data from the bus capacities, but I don't want to say too much about it right now, but since they're still working on the prediction data, but what they do see is what you would expect, I think, which is that when the weather is worse, the bus is more often at overcapacity. Whether that makes people more willing to accept the incentive or not, we won't know until we run the field experiment. So I'll tell you later when we run it.
Great presentation, thank you.
Thank you.
Can we go back to the table? I was confused about the, where you're showing the, yeah, so I thought you said that that the 50% chance of 30 minutes was higher, that they valued that more. So is this a typo, or is that the 30-minute line is showing $5, but the 50% is only $3.38?
So
And
this is the willingness to accept money, right? So in this one, there's a 50% chance of a 30-minute delay. So the expected wait is 15 minutes. But if it's a certain wait for 15 minutes, if you pay me $2.30, I'm willing to take that wait. But if it's a lottery between a 30-minute wait, 50-50 lottery between a 30-minute wait and leaving now, you need to pay me a lot more in order to take that lottery.
But the difference between the 30-minute and the 50% chance of 30-minute, it's actually lower for.
So this is a certain wait. This is for sure you have to wait for 30 minutes. To wait for sure for 30 minutes, I have to pay you $5.
Okay, thank you.
This is maybe a question more about the scope of your modeling effort.
Yeah.
With regard to maybe taking a little bit more a causal approach to the situation, the people are waiting there for some reason,
Right.
primarily because of employment. And I would guess for commute time. So have you did you look at extending the model to include as agents within here the employers, and looking at providing incentive for spreading out demand, or if not, how does a model like this interact with those things where, I don't know, an employer will be entered in a drawing where they may win some of their property taxes, by letting people choose when they're going to leave,
Yeah.
or when they're going to arrive, more likely,
Right.
at 8 in the morning.
So that's a really interesting point, right? So a lot of people's inability to substitute delays for money is because their employer's inflexibility, right? So in our situation, what we'll have is the distribution. We'll have all these people who are like at infinity or something that is really, really high. So I think the way we think about this is, one, yes, we could model the employer in the system, but it would require even simpler base models that we can put together in order to include the employer in the system. Yeah. But then we have to have kind of a different behavioral model for what it is that they're maximizing, and then integrate that into the current model. But it would be an interesting exercise. Another thing that we can think about is that when people leave work, they have a lot more flexibility in leaving work, and that is also some time when we have a lot of people being left by the bus. So maybe it extends to not so much to them going to work, but them coming back from work.
Well, thank you everyone for the great questions, and please join me in thanking our speaker. I will be thinking about my wait times very differently now, so thank you for this enlightening presentation.
Thank you.